I'm using the chi2 test, a statistical method perfect for figuring out which features in my dataset are most important for predicting customer churn. It's all about finding those features that are strongly linked to whether a customer leaves or stays. I have a dataset with 10 features, X, which are different characteristics about my customers, and the one target variable, Y, is whether the customer churns, leaves, or not. 0 for no churn, 1 for churn. I want to use the chi2 test to see which of the 10 features best predicts customer churn. I'm using the chi2 function from the popular Python library scikit-learn. This function is specifically designed to help me perform the chi2 test for feature selection. It's a super efficient way to analyze my data. The chi2 function gives me two important pieces of information: chi2 scores and p-values. The chi2 scores show how strongly each feature is related to churn. The p-values tell me the probability that the relationship I'm seeing is just due to random chance. Lower p-values mean a more significant relationship. I've set my significance level, alpha, to 0.05. This means I'm willing to accept a 5% chance of incorrectly concluding that a feature is important when it actually isn't. It's a common threshold in statistics. Based on the p-values from the chi2 test and my significance level, I will select features to include in my model. I'll pick features with a p-value less than or equal to 0.05, meaning their relationship with churn is statistically significant. It's like saying there's strong evidence that these features help me predict churn. I have a dataset with 10 features, X, representing different characteristics and a target variable, Y, indicating customer churn. Customer churn is a binary variable. 0 means the customer didn't churn, and 1 means they did. I'm using this dataset to practice feature selection. The chi2 function in scikit-learn gives me two things: chi2 scores and p-values. Each feature gets its own score and p-value. The chi2 score shows how strongly a feature relates to customer churn. The p-value tells me if that relationship is statistically significant. Alpha is my significance level. I set it to 0.05, which is a common choice. This means I'm willing to accept a 5% chance of incorrectly saying a feature is important when it actually isn't. My data has 10 features, characteristics of customers, like age or usage, and one target variable: whether each customer churned, yes or no. Based on my p-values and alpha level, I'll choose the features that seem most likely to be genuinely related to customer churn. Features with p-values below 0.05 are statistically significant, according to this test. I use chi2 from the sklearn library to calculate chi2 statistics and p-values for my features. This statistical test helps determine which features are significantly associated with customer churn. I'm performing feature selection using the chi2 test. This means I am figuring out which characteristics of my customers, the features, are most important for predicting whether a customer will churn or not. I will decide which ones to keep and use in further analysis. I'm using the chi2 test, a statistical method to figure out which features are most important for predicting customer churn. It's a great way to do feature selection. I have a dataset with 10 different features, things like age, income, etc., represented by X, and one target variable, Y, which indicates whether a customer churned, left the service, or not. 0 means no churn, and 1 means churn. I'm using scikit-learn's built-in chi2 function to perform the chi2 test. Scikit-learn is a powerful Python library for machine learning. The chi2 function gives me two important things: chi2 scores, which show the strength of the relationship between each feature and the target, and p-values, which tell me if that relationship is statistically significant. Think of the p-value as a measure of how likely it is that I saw this relationship by chance alone. I set my significance level, alpha, to 0.05. This means I'll only consider a relationship to be truly important if there's less than a 5% chance I observed it randomly. It's a common threshold in statistics. If a feature's p-value is less than or equal to 0.05, I'll select it for further analysis. This is because it likely has a real relationship with customer churn and isn't just random noise. Based on the p-values I get from the chi2 test, I decide which features are strong predictors of customer churn and should be kept for further analysis. The chi2 test helps me eliminate features that are not useful. Think of it as a feature filter to keep only the important ones. In this case, features 3, 4, 7, 9, and 10 all have p-values below 0.05, making them statistically significant predictors of customer churn. I'm excited to use them. I'm using the chi2 test, a statistical method, to figure out which features are most important for predicting customer churn. It helps me understand which features are strongly related to whether a customer leaves or stays. Think of it as a detective looking for clues. I have 10 different features, which I'll call X, that describe my customers, like age, how much they spend, etc. My goal is to predict Y, which is whether a customer churns, leaves, or not. It's a yes, no question, a categorical variable. To perform this analysis, I use a handy function called chi2 from the Sklearn library in Python. It's like a pre-built tool that does the heavy lifting of the chi2 calculations. The chi2 function gives me two things. Chi2 scores, which show the strength of the relationship between each feature and customer churn, and p-values, which help me decide if that relationship is statistically significant. I set my significance level, alpha, to 0.05. This means I'm willing to accept a 5% chance of being wrong when I conclude there's a relationship. It's a threshold for statistical significance. I'll select the features whose p-values are 0.05 or less. A low p-value suggests a real relationship exists between that feature and customer churn. It's not just random chance. Based on the p-values I've obtained, features 3, 4, 7, 9, and 10 are the ones that meet my criteria. These are the ones I'll focus on. These are example scores from the chi2 function. Each number corresponds to one of the 10 features, showing how strongly that feature is associated with churn. Higher scores suggest stronger associations. These are the p-values corresponding to the chi2 scores. Remember, I'm looking for values less than or equal to 0.05 to select features. I'm using a dataset with 10 features, which I'll call X, and a single target variable, Y, representing customer churn. This Y variable tells me whether a customer left, 1, or stayed, 0. This is the information I'll use to select the best features that predict churn. I'm using the chi2 test from the Sklearn library. It's a statistical test that helps me understand if there's a relationship between my features, X, and the target, Y. Sklearn makes it easy to use. The chi2 test gives me two important pieces of information: chi2 scores, which indicate the strength of the relationship between each feature and the target, and p-values, which tell me the probability that the observed relationship is due to random chance. A small p-value suggests a real relationship. I've set my significance level, alpha, to 0.05. This is a common threshold in statistics. It means I'll only consider a feature important if there's less than a 5% chance the relationship between the feature and churn is just random. Think of it as my confidence level. Based on my p-values, from the chi2 test, and my significance level, I'll decide which features are most useful for predicting customer churn. I'll choose features that have p-values below 0.05. That means they are statistically significant in predicting churn. This is the core question of this problem. I'm using the results of my chi2 test to identify which of the 10 features are strong predictors of whether a customer will churn. That is, whether a customer leaves the service or not. This option suggests that features 1, 2, 5, and 8 are important because they have high p-values. This is incorrect. High p-values indicate a weak relationship, not a strong one. This option suggests features 3, 4, 7, 9, and 10 are important because their p-values are below 0.05. This is the correct answer, as these features show a statistically significant relationship with customer churn. While feature 7 has the highest chi2 score, meaning it shows a strong relationship, the p-value is what determines if that relationship is statistically significant at my chosen significance level, alpha equals 0.05. Other features might be equally or more important even if they don't have the highest chi2 score. This is incorrect. The chi2 test is perfectly suitable for this problem. I'm comparing a categorical target variable, churn or not, with other features. It's designed for such situations. I'm working with a dataset. It has 10 features, which we represent as X, and a single target variable, Y, which indicates customer churn. 0 for no churn, 1 for churn. This is our starting point for feature selection. The chi2 function in Sklearn gives us two things. Chi2 scores, which measure how strongly each feature relates to customer churn, and p-values, which tell us the probability that the relationship we see is just by chance. Lower p-values suggest a stronger real relationship. I've set my significance level, alpha, to 0.05. This means I'll only consider a relationship to be real if the chance of it happening by random coincidence is less than 5%. It's a common threshold in statistics. Based on the p-values, I will decide which features are important enough to keep. Those with p-values less than or equal to 0.05 will be selected. These are the features I'll select. Their p-values were all below my 0.05 threshold, meaning there is good evidence that they actually affect whether a customer churns. I'm using Sklearn's chi2 function, a statistical test to see how features in my dataset relate to the target variable, customer churn. It's perfect for categorical target variables, like mine. I'm performing feature selection, choosing the most useful features, using the chi2 test. This is a way to simplify my model and focus on the features that matter most. I'm using a dataset with 10 features, which I'll call X, and one target variable, Y. The target variable represents customer churn, whether a customer stopped using a service, 1 for churn, 0 for no churn. I use Sklearn, chi2 function to perform a chi2 test. This test helps me figure out which features are most important in predicting customer churn. The chi2 function gives me two things: chi2 scores and p-values. The chi2 score tells me the strength of the relationship between a feature and the target variable. The p-value tells me if this relationship is statistically significant, meaning it's unlikely to be due to chance. I've set my significance level, alpha, to 0.05. This means I'll only consider a relationship statistically significant if the p-value is less than 0.05. Think of it as my bar for evidence. If the p-value doesn't meet this, then I won't consider it strong enough evidence that there is a meaningful relationship. Based on the p-values, I decide which features to keep for further analysis. Only features with p-values less than or equal to 0.05 make the cut. Features with higher p-values don't have enough evidence that they affect the target variable. This shows example output from the chi2 function. Each number is paired. The first list represents the chi2 scores, while the second is the p-values. I'll compare the p-values to my significance level, alpha equals 0.05, to decide which features are important.